All right. I'm going to do a little recording here just for fun. All right, you'll probably hear people in the background. You'll probably hear Martha talking. All right, or Anthony helping somebody. It's all right. So we're just going to do some problems today. All right. This says log base 5 of m over log base 15 of m. All right. So we're going to do what's called the change of base. So right, log 5 of m, that's horrible m, over 1 times 1 over log 15 of m. So we're going to decompose this a little bit. All right, then we're going to do the change of base formula. With this one right here, we're going to write log of m over log of 5. Okay, times 1 over this. Now, this right here becomes log of m over log of 15. But if it's underneath the 1, it's going to become the reciprocal following this pattern. If I have 1 over n over b, that equals b over n. So I'm going to take this, I'm going to flip it. Okay, so watch this. I'm going to put the log of 15 over the log of n because this is underneath the 1. So even though this changes using the change of base formula, this, if it's underneath a 1, it's going to be the reciprocal. Hey, I can see some things I get to cancel out. Right there and right there. And so what are we left with? The log of 15 over the log of 5. And once again, we're going to use the change of base formula, which is going to convert that to log base 5 of 15. So log base 5 of 15 will be my final answer. And I'm going to put a little box around it like so. And then I'm going to search for it. All right, log 15. So, log, hey, look at there. There it is, answer choice D. Right there. Voila. Moving on. Next question. Have to rewrite things. Cool. I'll rewrite them. Alright, so here we go. This is b power of x equals y. And this is log base b y equals x. So here we go. 6 to the negative 1 equals 1 over 6. I'm going to write it as a logarithm. So this one would be log base 6, 1/6 equals negative 1. Now how do you check it? You go around the world. Is 6 to the power of negative 1 equal to that? Yes, it is. So that's going to be my first answer. My second answer is going to be really, really, really easy. I just have to go around the world. 9 to the power of negative 1/2 is equal to 1/3. That's how I change it from logarithmic form to exponential form. So I'll write those in. All right, so, gotta refresh. Oh, I already did that one. There we go. All right, so I'm going to type in log base 6, 1 divided by 6 equals negative 1, because 6 to the power of negative 1 equals that. And this one's the easy one. 9 to the power, so 9 to the power of negative, oh, I messed up there. Negative 1 divided by 2. Let's try this again. Negative 1 over 2 equals 1 divided by 3. See if that will work. 9 to the power of negative 1 over 2 equals 1/3. There we go. All right. Okay. Now we got to find which one is the following to this. Alright, so the very first thing I'm going to check for is I'm going to check for an asymptote. Alright, so my asymptote right here for this problem will be at a positive 4. Okay? Because 4 minus 4 gets me, so I'm looking for an asymptote at x equals 4. Alright, that's what I'm looking for. Alright? Now, this has a negative 2 in front of it. Okay? So if this right here, I'll look, 1 second. If this is my original logarithmic function right here, okay? If you have a negative in front of it, what's going to happen is it's going to end up reflecting across the x-axis, okay? So I'm going to go ahead and go to Desmos so you guys can see how to type that in. All right, y equals log functions. Oh. So there's our original one. Okay. So that y equals negative 2 and then I put in x, I think it's 4 minus x. Okay. Alright, so these right here, you'll notice now it's going up, and then there's the vertical asymptote. The vertical asymptote is x equals 4. So there's the vertical asymptote that goes with this one. Okay. Alright, and it passes through 0 and a negative 2, but this one passes through a 0 and a negative 4. So it's going to be the first one. Alright, I'll do one more problem here, applying logarithms. So we're going to find the exact solution and the approximate solution. So I'm going to do one more problem on this unit test for this issue. So we have 4 times 10 to the power of negative 3x equals 18. So the first thing I would do is divide both sides by 4. And you get 10 to the power of negative 3x equals, now that reduces to 9 over 2. But then I have to apply what's called the common log, or log base 10, to the left-hand side of the equal sign. Whatever I do to one side, I have to do to the other. Now the cool thing is, this right here just cancels 2 with 1. And all we have to do now is just drop down that negative 3x. So if we use the power property and bring it in front, this just becomes a 1, and all we're left with is negative 3x equals, now I'm going to rewrite this as log of 9 over 2. I'm not going to write base 10 because the common log, automatically, you know that that's base 10. And the final thing I'm going to do is divide both sides by negative 3. Now, I could write log 9 over 2 divided by negative 3, or I can also write negative 1/3 log of 9 over 2. And I like this better, okay? I like to put that right out there in front, because dividing by negative 3 or multiplying by negative 1/3 is the exact same thing. And then I'm going to use my calculator to type it in. Alright, so negative 1 divided by 3 log of 9 divided by 2. So it's going to give me the approximate answer, so it's going to be negative 0.218. So what I'm going to type in right here, negative 0.218, because it said rounded to the nearest thousandth, and the actual answer as a logarithm base 10 is negative 1 divided by 3. I'm going to hit the log, and I'm going to open up parentheses and do 9 divided by 2. Alright, so this is the exact answer right here. This is the approximate answer. Okay? I'm not going to do this one. That's going to be the last one that I do, but that's basically what you're doing on this unit test. It's testing all of your abilities of exponential functions and logarithmic functions.